All right, I know from that last video, a lot of you are probably like, what the hell just happened back there? So, of course, I'm not going to leave you in the dust like that. I'm going to slowly and methodically go through another example so that you can kind of get the hang of this Kirchhoff's laws thing, okay? All right, so remember, Kirchhoff's laws. We get all our equations from two simple rules. Rule number one says that all the currents entering and leaving a junction must sum up to 0, okay? Where are our junctions? Here and here, okay? And rule number two says that all the voltages adding and subtracting around any given loop must also add up to 0, okay? All right. Second step, after we remind ourselves of that, second step is we want to pick the direction of our currents. Okay? Remember, this is totally arbitrary. We just know that currents must split every time we get to a junction, right? So in this case, there's going to be 3 currents again. Here, through this middle part, and through this bottom part, right? How do I know that? Well, through this top part, the current doesn't split off anywhere, right? So this must all be the same current. Through this middle part, the current doesn't split anywhere, so that must all be the same. And through this bottom part, the current doesn't split anywhere, so that must be the same, okay? And so I decided this time that I was going to create one current from here to here, right? And I was going to call this I1, okay? And I was going to make another current from here around through here, right? And I was going to call this I2. Do it over here. So this is I1 and this is I2. And I'm saying that inside here, throughout this entire region here, this is I3. Okay? All right. Remember, totally arbitrary. You could have picked I1 here. You could have called this I1, I2 if you wanted to. Doesn't matter. If you get a negative answer, it just means you picked the wrong direction. That's all. All right. So this would be the third step. Third step is we then do our little current law, a little junction law, right? And so let's say, just look at this one junction. We have I1 and I2 entering this junction and I3 leaving it, right? In other words, this means that I1 plus I2 should equal I3, right? We have 2 streams flowing into the junction and 1 stream flowing away. The streams flowing in must equal the stream flowing away. I1 plus I2 equals I3. Okay, take a deep breath. And now we go to a loop law. Let's see how it works. All right. Well, let's take the top loop first, because why not, right? And I'm going to start here, and I'm going to march around. Why am I going to do it counterclockwise? Well, because, you know, I like to go in the same direction as the current as much as possible. Maybe that's it. I mean, if you could pick any direction, you could pick clockwise or counterclockwise, doesn't matter. But I kind of like picking the direction that I set the current. Makes the problem a tiny bit easier, maybe. So if you want to do that, go for it. But I'm starting here. I'm going to go around this loop, and I'm going to end here. Okay? All right, let's do it. So march, 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 march. Oh, I get to a resistor. Am I going in the same direction as the current? Yes. So that's going to be a minus 3I1. Okay? March, 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 march. Oh, I get to a battery. Am I going from negative to positive? Yes. So that's a plus 10 volts. Okay? March, 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 march. Oh, I get to 2 ohm resistor. Am I going in the same direction as the current? Yes. Again, I subtract minus 2I1. Okay? March, 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 march. I get here. Am I going in the same direction as the current that I set? Yes. I3 is this way. So that's going to be 1I3, or just, yeah, so it's going to do 1I3. So that's minus 1I3. Okay? March, 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 march. Oh, I get to a 5-volt battery, right? Am I going from positive to negative? Yes. Okay, here I was going negative to positive, so I added. Here it's positive to negative, so I subtract, so that's minus 5. Okay, and then march, 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 march. Oh, I get to another 4 ohm resistor. That's going to be a minus 4I3, all equal to 0. I may have lost you on the edge here, but it's a minus 4I3 equals 0. Okay? Now let's simplify that, because there's a lot of terms here we can simplify. Let's start with the I1s. I1s, well, there's a 3 and a 2, so it's minus 5I1. Okay? Let's go with the I3s. Again, there's a minus 1I3 and a minus 4I3, so that's minus 5I3. Okay? And then we have a 10 and a minus 5, so that's only plus 5 equals 0. Okay? And so then that means that I have minus 5I1 minus 5I3 equals minus 5, right? All minus signs, right? That makes life a little bit easier. I can go ahead and I can cancel all those minus 5s, minus 5, minus 5, cancel. So that would give me I1 plus I3 equals 1. Whew. All right. All right. Take a moment to breathe and realize all this nastiness really just converts to this one simple little equation. We have 2 equations, 3 unknowns so far, and we're well on our way. I would love to tell you that I'm going to erase all this and just replace it with that. Okay, so I1 plus I3 equals 1. How much more simple is that? That's amazing. Okay. All right. Next loop. Let's do the bottom loop. And I'm going to start here and I'm going to march all the way around until I get back over here. Let's do it. Okay. March, 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 march. Oh, I get to a resistor. That is I2. Make that a little bit more clear. So this would be, I'm going in the same direction of the current, so it's minus 10 I2. Okay. March, 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 march. Oh, I get here. Same direction as the current. That's minus 1 I3, or just minus I3. Okay. I get to a battery going the negative side. March, 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 march. Positive to negative. That means that I'm subtracting 5. Okay. March, 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 march. Again, I subtract because I'm going in the same direction as the current. Minus 4 I3 equals 0. Let's combine terms, a little less ugly. So that's going to be minus 10 I2 minus 5 I3 minus 5 equals 0, right? Again, these negatives cancel. I'm just going to make that all positive. And I can divide a 5 out of all of these. Divide 5 by both sides, right? And so I just get 2I2 plus I3 plus 1 equals 0. And that means that I might as well just say all that equals negative 1. Right? Okay, I like that. All right. So this means that I am going to erase this right now and then just replace this up here with 2I2 plus I3 equals negative 1. Okay? We have 3 equations, 3 unknowns. All right? And you may remember that the best way to solve these equations is substitution, right? So where do we want to start?